There are advantages and disadvantages to installing an emergency generator for each building or one larger generator for all 3 buildings. The best solution depends on a number of factors. If installing an emergency generator for each building, the pros are firstly, redundancy. Having a generator for each building provides redundancy in case one generator fails. This can help to ensure that critical systems, such as elevators and fire pumps, remain operational in an emergency. Secondly, cost effectiveness. Installing a smaller generator for each building may be more cost effective than installing a larger generator for all 3 buildings. Thirdly, flexibility. Having a generator for each building allows for flexibility in terms of scheduling maintenance and repairs. The cons are firstly, space requirements. Installing a generator for each building requires additional space which may not be available in all locations. Secondly, increased maintenance costs. Multiple generators require more maintenance than a single generator. This can lead to increased operating costs over time. If installing one larger generator for all 3 buildings, the pros are firstly, reduced space requirements. Installing a single generator for all 3 buildings requires less space than installing a generator for each building. Secondly, lower maintenance costs. A single generator requires less maintenance than multiple generators. This can lead to reduced operating costs over time. Thirdly, increased reliability. A larger generator may be more reliable than multiple smaller generators. This is because a larger generator is less likely to fail due to overheating or other factors. The cons are firstly, lack of redundancy. Having a single generator for all 3 buildings means that there is no redundancy in case the generator fails. This could lead to a loss of critical services in an emergency. Secondly, increased cost. Installing a larger generator may be more expensive than installing multiple smaller generators. The best solution for the particular application will depend on the specific factors involved. Careful consideration of the pros and cons of each option should be made before making a decision. Some additional considerations that may be helpful are firstly, the size of the buildings and the number of people they house. Secondly, the criticality of the systems that need to be backed up by emergency power. Thirdly, the availability of space for generator installation, and fourthly, the budget for the project. Once all of these factors have been considered, an informed decision about the best solution for the needs can be made. When considering the size of the buildings and the number of people they house, the total load demand for each building should be carefully calculated. This includes not only the emergency loads such as elevators and fire pumps, but also the community room lights and power as required by the National Fire Protection Association or NFPA. The larger the building and the more occupants it houses, the greater the emergency power demand will be. This may necessitate a larger generator or multiple generators to ensure adequate power supply during an outage. When assessing the criticality of the systems that need to be backed up by emergency power, it is important to prioritize the systems that are essential for life safety and building operations. Elevators, for example, are critical for evacuating occupants, especially those with mobility issues. Fire pumps are essential for suppressing fires and protecting the building from damage. Community room lighting and power may be necessary for providing a safe and comfortable environment for residents during an emergency. The more critical the systems, the more important it is to have a reliable and redundant emergency power system. When evaluating the availability of space for generator installation, factors such as zoning regulations, building codes, and site constraints should be considered. Generators require adequate ventilation and exhaust systems, as well as space for fuel storage and maintenance access. If space is limited, it may be necessary to locate the generator on the roof or in a separate enclosure. The cost of installing a generator can vary widely depending on the size, type, and location of the generator. It is important to obtain multiple bids from qualified contractors and to carefully review the specifications and warranties before making a decision. A comprehensive cost analysis should include not only the initial purchase and installation costs, but also the ongoing maintenance and operating costs. Considering redundancy in emergency power systems is crucial for ensuring the reliability and availability of power during an outage. Redundancy can be achieved by installing multiple generators or by using a combination of generators and uninterruptible power supplies, or UPSs. If one generator fails, the other generator or UPS can automatically take over, providing uninterrupted power to critical systems. Evaluating the cost-effectiveness of different generator options requires a thorough analysis of the total cost of ownership over the life of the generator. This includes the initial purchase price, installation costs, fuel costs, maintenance costs, and repair costs. A smaller generator may have a lower initial cost, but it may also have higher operating costs due to lower fuel efficiency or more frequent maintenance requirements. Larger generators may have a higher initial cost, but they may also have lower operating costs due to higher fuel efficiency and less frequent maintenance requirements. Carefully assess the space requirements for each generator option, taking into account factors such as zoning regulations, building codes, and site constraints. Generators require adequate ventilation and exhaust systems, as well as space for fuel storage and maintenance access. If space is limited, it may be necessary to locate the generator on the roof or in a separate enclosure. Maintenance requirements for generators can vary depending on the type of generator and the operating conditions. Regular maintenance tasks include inspecting and cleaning the generator, changing the oil and filters, testing the battery, and inspecting the fuel system. A well-maintained generator will be more reliable and will have a longer lifespan. Assessing the reliability of different generator options requires a thorough review of the manufacturer's specifications and warranty. Look for generators that have a proven track record of reliability and that are backed by a comprehensive warranty. Larger generators may be more reliable than smaller generators due to their more robust design and lower operating temperatures. National Fire Protection Association, or NFPA, standards play a significant role in the design and installation of emergency power systems. NFPA 110 is the standard for emergency and standby power systems, and it provides requirements for the performance, installation, and testing of emergency generators. Compliance with NFPA 110 is essential for ensuring the safety and reliability of emergency power systems. Electrical design considerations for emergency power systems include proper sizing of the generator, selection of appropriate transfer switches, and coordination of overcurrent protection devices. The generator must be sized to handle the total load demand of the emergency systems, including elevators, fire pumps, and community room lighting and power. Transfer switches are used to automatically switch the load from the normal power source to the emergency power source in the event of an outage. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect the electrical system from overloads and short circuits. Additional factors to consider when evaluating emergency generator options include noise levels, emissions, and fuel storage requirements. Generators can be noisy, so it is important to select a generator that meets local noise ordinances. Generators also emit pollutants, so it is important to select a generator that meets environmental regulations. Fuel storage requirements will depend on the size of the generator and the anticipated duration of power outages. Local codes and regulations should be consulted to determine the specific requirements for fuel storage. When evaluating the pros and cons of different generator options, it is important to consider the specific needs of the apartment buildings and the priorities of the stakeholders. If redundancy is the top priority, then installing a generator for each building may be the best option. If cost is the top priority, then installing a single larger generator may be the best option. If space is limited, then installing a smaller generator or locating the generator on the roof may be the best option. Ultimately, the best solution will depend on a careful balancing of all the relevant factors. Emergency power systems should be inspected and tested regularly to ensure that they are functioning properly. Inspection should include a visual inspection of the generator, transfer switches, and other components. Testing should include a load test of the generator to verify that it can handle the total load demand of the emergency systems. Regular maintenance, inspections, and testing should be performed by qualified personnel. The design of the emergency power system should be reviewed and approved by a qualified electrical engineer. The electrical engineer will ensure that the system meets all applicable codes and standards, and that it is properly sized and configured to meet the needs of the apartment buildings. The electrical engineer should also provide guidance on the selection of appropriate equipment and the installation and maintenance of the system. In addition to NFPA 110, there are other codes and standards that may be relevant to the design and installation of emergency power systems. These include the National Electrical Code, ONEC, which provides requirements for the safe installation of electrical wiring and equipment, and the International Building Code, or IBC, which provides requirements for the design and construction of buildings. Compliance with these codes and standards is essential for ensuring the safety and reliability of emergency power systems. The location of the generator should be carefully considered to minimize noise and emissions. Generators should be located away from occupied areas and sensitive equipment. Noise barriers and mufflers can be used to reduce noise levels. Exhaust systems should be designed to minimize emissions and to prevent the accumulation of exhaust gases inside the building. The fuel supply for the generator should be reliable and adequate to meet the needs of the apartment buildings. Fuel tanks should be sized to provide sufficient fuel for at least 72 hours of operation. The fuel supply should be protected from contamination and theft. Automatic transfer switches, or ATSs, are essential components of emergency power systems. ATS automatically switch the load from the normal power source to the emergency power source in the event of an outage. ATS should be selected based on the size of the load and the type of power source. ATS should be tested regularly to ensure that they are functioning properly. Uninterruptible power supplies, or UPSs, can be used to provide a seamless transition from the normal power source to the emergency power source. UPS provide battery backup power that can bridge the gap between the time when the normal power source fails and the time when the generator starts up. UPS are often used to protect sensitive electronic equipment from power outages. Surge protection devices, or SPDs, can be used to protect electrical equipment from voltage surges. Voltage surges can damage or destroy electronic equipment. SPD should be installed at the service entrance and at all critical loads. Grounding is an important safety consideration for emergency power systems. The grounding system should be designed to provide a low impedance path for fault currents. The grounding system should be tested regularly to ensure that it is functioning properly. Signage should be provided to clearly identify the emergency power system and its components. Signage should include information about the location of the generator, transfer switches, and other components. Signage should also include instructions for operating the system in the event of an outage. Training should be provided to building personnel on the operation and maintenance of the emergency power system. Training should include information on how to start and stop the generator, how to operate the transfer switches, and how to troubleshoot common problems. Building personnel should also be trained on the safety procedures for working with electrical equipment. The emergency power system should be documented thoroughly. Documentation should include a detailed description of the system, including the location of all components, wiring diagrams, and operating instructions. Documentation should be kept in a safe place and should be readily accessible to building personnel. Regular maintenance is essential for ensuring the reliability and longevity of the emergency power system. Maintenance should include inspecting and cleaning the generator, changing the oil and filters, testing the battery, and inspecting the fuel system. Maintenance should be performed by qualified personnel on a regular basis. Testing should be conducted on a regular basis to ensure that the emergency power system is functioning properly. Testing should include a load test of the generator to verify that it can handle the total load demand of the emergency systems. Testing should be performed by qualified personnel on a regular basis. Keep accurate records of all maintenance and testing activities. Records should include the date of the activity, the name of the person who performed the activity, and the results of the activity. Records should be kept in a safe place and should be readily accessible to building personnel. Periodically review and update the emergency power system design to ensure that it continues to meet the needs of the apartment buildings. Changes in building occupancy, electrical loads, or code requirements may necessitate changes to the emergency power system. The design should be reviewed and updated by a qualified electrical engineer. Establish a clear chain of command for managing the emergency power system during an outage. The chain of command should identify who is responsible for starting and stopping the generator, operating the transfer switches, and troubleshooting problems. The chain of command should be communicated to all building personnel. Develop a comprehensive emergency response plan that includes procedures for managing power outages. The emergency response plan should include procedures for evacuating occupants, contacting emergency services, and communicating with residents. The emergency response plan should be practiced regularly. Conduct regular drills to familiarize building personnel with the emergency response plan. Drills should simulate different types of power outages and should test the effectiveness of the emergency power system. The results of the drills should be used to improve the emergency response plan. Communicate with residents about the emergency power system and the emergency response plan. Residents should be informed about the location of the emergency power system, the types of loads that are backed up by the system, and the procedures for managing power outages. Residents should also be encouraged to participate in emergency preparedness activities. Coordinate with local emergency management agencies to ensure that the emergency power system is integrated into the community's overall emergency response plan. Local emergency management agencies can provide assistance with planning, training, and resource allocation. Consider the environmental impact of the emergency power system. Generators emit pollutants, so it is important to select a generator that meets environmental regulations. Fuel tanks should be properly sealed to prevent leaks and spills. The emergency power system should be operated in a manner that minimizes environmental impact. Explore alternative power sources for emergency power. Alternative power sources, such as solar power and wind power, can reduce the reliance on fossil fuels and can improve the sustainability of the emergency power system. Alternative power sources may be more expensive than traditional generators, but they can provide long-term benefits. Keep abreast of the latest technologies and best practices for emergency power systems. The field of emergency power is constantly evolving, so it is important to stay informed about the latest technologies and best practices. This can be achieved by attending industry conferences, reading technical publications, and consulting with experts. Remember that the best emergency power solution is one that is tailored to the specific needs of the apartment buildings and that is properly designed, installed, maintained, and operated. A well-designed and maintained emergency power system can provide reliable backup power during outages, protecting lives and property.